Hi, so this is going to be a demonstration of the PcodeSym extension that I've written for Ghidra. So the PcodeSym extension is just another way to analyze binary files, and the idea is that you can perform some kind of symbolic execution on a binary within Ghidra. So to demonstrate this, I've got this binary here called easy password. If you run it, it asks you to give a password, and if you put the wrong one in, well, it just prints out wrong. So this binary was actually created by Adrian Herrera as part of a CTF challenge. But let's go ahead and load it up into Ghidra and see what we can find out about it. So we'll import it in, and another thing I recommend when loading in a binary into Ghidra is to tick this load external libraries box, and that will make sure that any shared libraries which the binary depends on are also loaded in. So we'll open it up, and since it's a brand new binary, it's going to prompt us if we want to analyze it. So we're going to tick yes. And we'll just wait a little bit for it to do some analysis, and then we'll jump to the main function. Alright, so it looks like not everything in here has been analyzed yet, like these strings here are not populated, so let's just go ahead and see what these strings are. So we can just grab that one and format it as a string. So we can see that this one's printing out, please enter your password, and don't enter more than 64 characters like what we saw in the terminal. And this one is going to read 64 characters from standard in. So we can see the scanf is using this format string to read 64 characters. And then we're going to call this check password function, and we're going to take the return value of that, and depending on if that value is equal to 1 or not, we're going to print one of these two strings. So let's see what the first one is. So the first one is your password is the flag, and the second one is, well, it's wrong pretty much. So I think if we format this, we can get it to show up in there. There we go. So it's either going to print your password as the flag, or it's going to print wrong, depending on what is returned by this check password function. So obviously we want to get this outcome, which is your password is the flag, which would mean that the check password function is going to have to return 1. So let's have a look at this check password function. So one thing to notice about it is that it's taking a long time to analyze this, and that's actually because this is a really sort of complicated function. So the nature of this function, even when it does finish analyzing it, it's not very readable, just because it's actually a function that was created by a program, and it's pretty much like very obfuscated kind of code. So I found that a better way to look at it is actually to use the function graph in Ghidra. So yeah, as you can see, there's lots of branching going on, lots of things happening here. But in the function graph, you can kind of look at it more as a collection of shapes rather than as code. So if we come in and look a bit closer, the first one here, we can see it's going to print something to standard error, incorrect password. So using the PcodeSym extension, I'm going to say, well, if this is saying incorrect password, I'm going to want to try and avoid that. So I'll add this block here to the avoid addresses, which I don't want to symbolically execute. And this is the start of the function. So as we saw before in the main function, we're going to read in 64 characters. So I'm going to go ahead and go to source address, and we're going to add an argument. So we can choose whether this is a concrete or symbolic argument. We're going to choose symbolic because we don't know what that is now, and we want to figure that out. And in here is where we're going to put, if this was a concrete, we'd put in the sort of concrete bytes that we want in there. But since this is symbolic, what we do is we put in however many characters we want the length of the symbolic vector to be. So because we want it to be a 64 characters, we'll go ahead and get 64 characters. So that's 64 X characters, and we'll just paste that in here. So it doesn't have to be X, it can be any character. Alright, so we've got the start, and we've got this address which we want to avoid. So, like I was saying, like this is not very readable code, but we want to find where in this it actually returns 1. So we'll look for a return 1. I just did a Control F then, and we'll see if we can find it. So there's at least one place where it returns 1, and that's the only place. So this here is really where we want to end up. So if we look on the function graph, it's here, right at the end of this sort of big long chain of tests and branching and things like that. So this is where we ultimately want to end up. So I'm going to go ahead and say this block of code here, this is sort of my success condition. If I reach this block of code, then it's a success. And then all of these blocks here, one thing to notice about them is that they all end with this sort of J and Z instruction, which is like a conditional jump saying if this is not equal to that, then jump this way, otherwise just continue along here. And in each of these cases we actually want it to sort of keep going along here. So for all of these jumps we actually don't want to go to where they're jumping to. So obviously this is, there's so many of these, it takes so long to add this by hand. So what I've done is, if we go back to the start here, I've actually got a script that'll do this for us. So let's go ahead and copy this first address, and we'll just write it down somewhere. If it wants to do that. Okay, apparently that's not working, so we'll just go ahead and type it in. And then we'll go ahead and also get the last address. So this is the last J and Z, and this is just after that, so we'll grab this one. Not sure why this isn't working, but we'll go ahead and type it again. Alright, so this is the first address, and this is the last address of this sort of big chain of blocks of code where we want to always take the not jumping option and never take the jump option. So then I've got this script which is in the scripting manager here, and if we just take a quick look at what this script does, so basically it asks us for the starting address, asks us for the ending address, and then gets the address in the code browser and gets the last address, and then loops through while the instruction that it's looking at is not equal to the last instruction. It compares the mnemonic of the instruction, checks if it's a J and Z instruction, and then if it is, we look at the operand of that instruction and basically add that address to the addresses that we want to avoid. So we can see here I've imported this Ghidra concolic analyzer. That's part of the API from the PcodeSym extension, and it's got this function here which lets us add an avoid address through the scripting interface. So we'll go ahead and run this script. And so for the first address, we'll want to use this one here. And for the last address, we'll want to use this one here. So it's finished. That means it's added all of those addresses that we want to avoid in the symbolic execution into that list. So then we can finish up by running the actual symbolic execution. So I've just got this run solve script here, which actually starts up the Ghidra bridge and runs angr, and then angr talks back over the Ghidra bridge to the API, which I've got for the PcodeSym extension, gets all of those parameters which we set using the the menu here, and also that script, and basically runs the symbolic execution. So let's run that and see what happens. So it takes a few seconds. Alright, we're finished. So here we go. That first argument which we set, which was that, string that could be up to 64 characters, it actually has evaluated to this, obviously this looks like a flag for a CTF. And yeah, so it took about 13 seconds to run. So yeah, I guess that's everything. That's solving this challenge binary using this PcodeSym tool. Actually, let's just go ahead and test it and make sure it actually works. So we'll just copy this and let's run it. There we go. So your password is a flag. We get some confetti. So yeah, there we go. We did it. We solved it.